Yes, Nicole.
How do you get the formula to save in Y1?
How do you get the formula to save in Y1? You mean like how I did originally?
Yeah, like what you did right there.
No, this is the second time. You mean this move right here?
The first one, like the Y1.
You mean up here?
Yeah, how'd you get all the data?
Press the stat button. Okay. You press the stat button, right? You access your regression. We picked exponential, right?
Yeah.
You, comma. You with me so far?
Yeah.
Then you press this button, VARS, for variables. I believe that's what it stands for. You look, you scroll over to YVARS, pick one per function, and decide where you're going to save it. Then it takes you back to the main screen. You'll see X regression or X reg, comma L1, comma L2, comma Y1. Hit enter. It'll give you all the data. But if you now press the Y equals button, you should see the formula saved.
Okay. All right.
Okay. So I don't know if this works. I don't know. You guys can tell me. I don't know what Zoom Fit does, but I think it'll help us a little bit. It doesn't really matter.
It takes forever to load.
Oh, is it thinking about it? Okay, so this means it's thinking right here. So I disengaged the Y1, right? So I should just be seeing Y2 and Y3.
Nice.
Oh, that's so beautiful. That's just brilliant.
Okay, so I think this one was shown first, so maybe the intersection is happening over here, or maybe I made a mistake. So I'm gonna decrease my range. My range is way too big. So I'm gonna go window, and I'm gonna go to the top, the Y max, and I'm gonna make it like, I don't know, 100, and I'm gonna press graph again. That's a little bit better, right? Where's my other graph? Okay, it's close, right? So I can't see the intersection, so I shaved off too much. So why don't I go to like, I don't know, 200. Do you guys understand what I'm doing? I'm playing with that window so that I can see what it is I want the calculator to find. One graph. I think I'm pregnant, Arish. I'm eating like a pig the last 2 days. Every day I just eat and eat and eat and eat.
That's what happens when you cheat on me.
I go out and get pregnant. Oh, that's what happened? I got pregnant.
Don't go outside, ladies. You'll get pregnant.
No, because of my version food.
Those were good, man. Those were really good.
I listened yesterday.
Yeah.
So what? Those things will last for a few days. Okay, good enough? Good enough? That's what we want, right? So, how do we access that point of intersection? What feature was it? Hello? No! Calc. Second function? Yeah. Which option am I picking? Yeah. Okay, so it's asking me, is the first curve I want in the intersection, see how it's flashing on this one? Is it, but you can look, do I want Y2 involved in the intersection? Yes, I do, because that's the 10% of bad guy curve. So you hit enter. Okay, because you want it involved in that intersection. Then it's asking you, is the second curve you want in the intersection this one, Y3? Yeah. Excuse me, it is. So I hit enter. Then it gives me an initial guess. In this particular case, is this guess close enough to where I want, where the actual answer is visually? Yeah. So I hit enter, and then it should give me the information. Okay, so it's telling me 10.7 years. Next.
How are we going to mark that?
Well, how are we going to mark that? Just give them. It's going to be 1.5 or 3. I mean, a proper answer is a 3, and anything else is 1.5. This is basic. This is a senior course. If you're getting 1.5s on everything, there's nothing to be. You can't really use that as a mark. So you need to start getting 3s on these kinds of things. Chris, seriously, come on.
I know. I'm just trying to find what is what. I'm zooming in a lot on your face.
It's fine, but who would have benefited from having the solutions for the first 2 questions on tape? Yeah, they're gone now.
It's a witch hunt for Chris.
Come on.
Yeah, we're all good now.
Okay? It makes it easier for me too because they can just go online and reference.
Gotcha.
Come on, just be aware. Okay, Nicole, it wasn't that bad though, right? I mean, you can get that.
Yeah, like the first part is just the actual explanation why.
You want the explanation of why again?
It was there.
You're okay?
Copies, kids.
Very quickly again, when you're sampling the data, you're not likely to grab the outliers. Outliers have major impact on the result of standard deviation because it's deviation squared. Outliers give you a very big contribution to square deviation, and that's not there because you didn't grab them likely, and if you didn't grab them, your answer would be too low, and so we artificially inflate the result by putting a -1 in the denominator to make the result bigger, to more correctly reflect reality, which would be a sampling of the entire population. Okay, so that's one thing. All right, let's do it. We're doing the proof, and that's it, right? Do you want to do the proof, or do you not care?
Yeah.
Okay, I figured it was a good one to do one that I assigned because you guys were never bugging me to take it up, and there were some conscientious students that came in and they were like, they were like, can you take it up? So
Exactly what we were like. Without giving you half of my bill.
Guys, I need more chalk.
Oh, Myers Things has some chalk.
Myers things?
Oh. Yo, no, it's gonna break. It's gonna break.
I'll throw it.
Give it to the baseball player. It's white on white, that's what's tough.
White on white.
No, you stole my chalk.
No, it's because you're throwing it, look, you're throwing it like that, so it's coming down on white. If you threw it straight, it would have been easy.
You tell us, guys.
Zoom out and then see what
I don't know what it is.
Take it outside. Watch me lose a bunch right, left side, and right side.
Watch me toss up on the board.
Okay, now, I want to finish this. I love to finish this. It would be so nice for me to not teach to the end. Okay, the first thing that you have to recognize, everywhere you see sigma x, remember, what it really means is by default, when there's nothing below or above, there are no limits, it really means start at 1 to the max of xi, okay? But like the textbook, the remedy, I'm just going to write sigma x, given that we all understand that when this is written, I mean that, okay? So x is not a constant, it is a variable, running from 1 to n, okay? So I'm asking you to do a proof. So typically with proofs, how many of you guys had not done any proofs before this course? Okay, right, you've all done something, right? So most important thing, the question was prove that this equals that, but you don't know that they're equal, so you separate them, you indicate a left side and a right side, and they are separate, and if you can show that one is the other, then you know they are equal. You never have equal signs running down a proof, never, that's automatic mark deduction. And therefore, since they're not equal, you can't start moving things back and forth, because that violates, the logic is backwards. It's like, prove that this equals this. And then you start moving something over to the other side, well then there's no proof. That means you're already assuming they're equal, right? You can only start moving things to other sides of equations once they're equal, which defies the purpose of the whole point, the whole thing, yes.
What if they put equal signs down the thing?
They're going to lose marks.
Like how?
Not a lot. I don't know, I haven't decided.
Sir, what if they did like, because that is...
Okay, can we do that
No.
at the end?
Listen, it's important because some people might have done that. You know, it's 2 expressions equals 0. What if they did 1 expression equals the other? So the positive.
That's wrong.
No, that is right.
That's wrong.
No, because they must be the same if they're equal to 0.
It's wrong though, technically, right?
Why can't you do that?
Because what you're doing is you're saying that...
But you're saying that equals 0.
Yeah,
so why can't that be that?
I guess
they must equal the same thing.
Because you're subtracting them. So
Yeah.
technically you're not moving it to the right of the equal sign. But it's not a left side, right side thing.
But then you split it up left side, right side. So you're saying that left side has to equal.
Well, it's wrong technically because what you're doing is you are adding this to both sides of an equation so that this goes away and then it ends up over there. Right? So you're saying if you know that A minus B equals 0, then A should equal B. So you're saying, oh, I'm not going to prove this, I'm going to prove this. Okay?
Why can't you prove that?
Because to prove this, you are presupposing that this is already true. But you've got to prove that.
Well, no.
But in a way, it's true because what you're saying is you have an A, you have a B, and if they are the same and you subtract them and you get 0, then that is what is equal to the right side. So what I would prefer, I would much rather prefer you just write the entire left side, okay? I want you to do this. I'd like to see a left side, a right side. The right side doesn't have to be big. You can make it really small on the right. You know, like 0 over here, and use all the space for the left side. Write the entire left side of the equation. It's much easier for me to mark, or anybody else to mark. And then I can just follow the flow. Okay? Is that clear? I understand what you're saying. You're showing that this is equal to that, and then the difference between the two is nothing, which equals the right side. But it's annoying. Okay?
But it's not.
It's annoying to mark. It's really annoying to mark.
It's actually easier to mark.
No, it isn't. It's way easier as a marker for me to just focus on one side or the other and follow your work. I don't have to go looking here for A, I don't have to look for B, and then I don't have to see, oh, A is equal to B. They'll all be right in front of me, vertically. Okay, so we went through this. Some of us went through this because you asked me about it for extra help. What was the logic, Shiva, that I told you that I used to solve this question?
That n x bar equals sigma x bar.
Sigma x over...
And
Yeah, I mean, the bottom line is you have a lot of sigma x's in here, right? And you have a lot of x bars. But you should remember in your mind that by definition, x bar is sigma xi from 1 to n over n, right? So what I figure is, if you return, I mean, this is not the only way you can do these things. As you know, these proofs you can do it many ways. This is the way I figured. It's like you have apples and you have oranges. But if I know that oranges can be expressed in terms of apples, I want to express them in terms of apples. That way I'll only have apples to deal with in front of me.